Welcome to EDU World Space.
Okay, so question is to use iterative analysis to determine the diode current where VDD is 1 volt, R is 1 kilo ohm and IS is 10 raised to minus 15 ampere and the circuit is given here. Okay, so we can start by assuming that the voltage across the diode is, let's say, 0.7 volts, that because that is the general value that we have for voltage drop across a diode. So we'll rate this as VD as 0.7. Now we'll use our iterative method. So now we know VD, so we can calculate current ID. So ID will be change in voltage divided by resistance. So here we have change in voltage, that is VDD minus VD over resistance R. Now VDD given to us is 1 volt minus 0.7 divided by 1000 gives 0.3 milliampere. Okay, so we know the current now for this given value, but we don't know if this is correct or not. So we have to check what is the VD based on the equation of voltage across the diode. So we have VD is equals to VT times ln of ID over IS. Now here VT is the voltage dependent on the temperature and the saturation values. So that is for normal diode, or for this given diode is 0.025 times ln of ID. We have calculated 0.3 milliamperes, which is nothing but 0.3 into 10 raised to minus 3 amperes divided by IS given to us as 10 raised to minus 15. On calculating this we get 0.6607. So from this we get VD as 0.6 and here we 0.7. So now we have one step closer to the actual value. So now we can again use the same procedure. So this was first time. Now we'll do it the second time. So we'll calculate ID for this. So ID will be 1 minus, that is same formula here, so 1 minus 0.6607 divided by 1000, and that gives us 0.339 milliampere. Now again based on this ID we'll calculate VD. So VD will be 0.025 ln of ID new one is 0.339 into 10 raised to minus 3 divided by IS, which is again 10 raised to minus 15. And on solving this we get VD is equals to 0.6638 volts. Now for third iteration we'll again use our obtain ID. So 1 minus 0.6638 divided by 1000 gives us 0.3362 milliampere. And now calculating VD for this, so we have again same formula, 0.025 ln 0.3362 into 10 raised to minus 3 since milliamperes divided by 10 raised to minus 15, and this gives us 0.6635. Now if we see here, this value is approximately same as our previous value 0.6638, right? So now we can calculate our ID, and that will be 1 minus 0.6635 over 1000, and that gives us 0.3365 milliamperes. Now since value is not changing significantly, so we can take this as answer. So our VD, voltage drop across diode, is 0.6635 volts and current through the diode ID is 0.3365 milliampere, and that's our final answer. Thank you.